properties. We're going to be looking at convexity of the bonds and how an adjustment is made for that. We will apply that to calculating the return of bonds and see how risk is related to its duration and convexity. And then finally, we'll be bringing it together with calculating the duration and convexity of a portfolio. Now, what have we discussed so far in previous learning modules is that a bond doesn't move in a straight line. The price of a bond is convex, right? So here's your bond price, and here are your changes in your yield to maturity. And as interest rates go up, bond price comes down. As interest rates go down, bond prices go up. So we know this inverse relationship is there, but it's not a straight line. It's not a straight line. It is a convex relationship, which means when it goes up really fast, but when it comes down, it doesn't come down that much. And therefore, it is a convex relationship. And if we want to know what the bond price would be if interest rate is going down, then if we just assume a straight line, then that straight line would tell us that if the interest rate was going down, the bond price would go up. But that would not be an accurate estimate because we know that it is convex and not in a straight line. So that means we need to make that estimate of the convexity adjustment, that how much would it go up if it were to go up, and again how much would it come down if it were to come down. So that is the convexity adjustment. We will then apply it to calculate the percentage change given a bond's duration and convexity. And then finally, what we will talk about is if we had a portfolio of bonds, how do we add up their specific respective duration and convexity for the entire portfolio. So as discussed, let's say this is 10% YTM, and if your YTM is going down to 9%, clearly the price would go up, right? So price of the bond would go up. And as far as what we've discussed previously, where we were calculating the MACD and based on that we were calculating the mod D, it would give us an estimate. Let's say from $1,000 the price is going to $1,100, but that is based on this linear relationship that we are assuming, this straight line, right? But of course we know that it's not a straight line, it's a convex relationship. So the bond price, as you can see, is going up more than that. It is not just going up this 100, it is going up actually 200. And this, the remaining part, is the convexity adjustment. This is the convexity adjustment that needs to be calculated and implemented, right? So that's to the upside. If interest rate is coming down, the bond price is going up more than what your mod D tells you. But look at what happens on the downside. If your interest rates go up, let's say they go up to 11%, now your mod D would tell you that interest rate, the price should fall a lot, right? Maybe it will tell you that it will fall to 900, but actually it is not going to fall that much because there is a convex relationship. And let's say it falls to 950 only. So that amount that it didn't fall, again, that is the convexity adjustment that needs to be calculated. And this is what we're going to learn how to do. So what did we talk about so far? We said, yes, there is assumption with duration that it assumes a linear relationship. Is that true? Well, in reality, it is not true, because in reality, what we have is a convex relationship, right? And this duration could be a good measure for small changes. So if your YTM is changing very little, so I mean the price that you will get from duration will not be that different from the real price. But if your YTM is changing a lot, then clearly the price that your duration will tell you is going to be a lot different than the actual price that might be there in the market. So therefore, if either you're expecting large changes in interest rate or you're expecting a high amount of volatility, well, then you need to take the convexity into account and you need to make an adjustment for the convexity. So how does one do that? because so far what you have learned is that you calculate your mod d. And how do you calculate that? Well, you could take your MACD and calculate your mod d from that. If you have forgotten, let me just refresh your memory. So MACD was your weighted average time till you get your payment back, and that is obviously weighted by years, and then we would divide that by 1 plus the YTM to give us the mod D. And then the mod D would basically tell us that, okay, if you have your modified duration and you multiply, so mod D basically tells you what the price change in percentage terms for a bond would be for a 1% change in yield, right? And then whatever your change in yield is, you multiply it with your mod D and you get your price change, percentage change in your bond. But now, in addition to that, what we are doing is that we're calculating that part which is your duration adjustment, right? But then we are also adding to that a convexity adjustment, right? Because clearly, if the bond is expected to go up, right, it we need to calculate how much up, but then we need to calculate a little bit more because of that convexity part. Or if it is expected to go down, right, we need to calculate how much down, but then how much it will not be going down because of the convexity. So that part needs to be separately calculated and added. Now let me just again refresh your memory that how are we calculating mod D? Well, mod D was coming from your MACD, right, divided by 1 plus YTM. But MACD is a very complicated calculation. It takes time to calculate the weighted average number of years till you get your money back. So we looked at another way of calculating mod D, and that was your approximate modified duration, and that was calculated based on the PV minus and the PV plus, where we were taking the price of the bond when interest rates were going down and the price of the bonds when the interest rate were going up, and based on that we were calculating your approximate modified duration using the formula. And that's the same way we're going to calculate our convexity as well. And let me show you that formula. So this is the formula for approximate convexity, similar to your approximate mod D or your approximate modified duration, because here we're also taking the price when interest rates are going down and we're taking the price where interest rates are going up. But instead of subtracting those two, we are actually adding them together, right? And then what we're subtracting is 2 into the value when interest rates haven't changed, right? So what you're essentially doing is you're saying, okay, this higher price, this lower price, what my original price was, let me add these two together. So let's say that is 1100. Let's say this is 950, right? So you will add 1100 and 950, and then you will minus from it that original price of 1000, but into 2. So it will be 2 into 1000, right? And what you're essentially getting is the distance between these two, right? Because you added them together and then you subtracted the starting price into 2. So you're actually getting the distance from the original amount, right? For both of these. And then you divide it by the square of the yield change multiplied with the price, and this is what gives you the convexity, approximate convexity. Now you can try and intuitively remember this formula, or you could just memorize it, right? It wouldn't hurt to memorize it. This is one of those formulas that you might need to memorize, and you could take a note of it, and just before the exam you could have it on your list of formulas that you just look at before you walk into the exam. But this is the formula that you need to know, right? And then of course, just like with your mod D, where we had our mod D and we multiplied it with the price to calculate our money duration, right? Here also, if you take your approximate convexity and you multiply it with your price, you will get your money convexity, which is just going to give you the dollar amount of change in the price for a given change in yield, right? So that's your formulas. And in the next section, which is 3, we're going to apply these formulas, and I will make sure that you know how the application is done. But before we get into applying those formulas, let me just talk a little bit about convexity, that it's actually a good thing, right? Because bond price is going up more than what your duration is telling you, right? And the more convex the bond, the higher the price is going, right? And the more convex the bond, the lower the price is falling. So look at this more convex bond. This is so nice because when it's going up, it is going up a lot, but when it's coming down, it is not falling that much, not falling as much, right? But going up very fast. So on the upside, it is very fast to go up. On the downside, it's very slow to fall. So therefore, convexity is a good thing. Now the question is, where does it come from, right? Where does it come from? And is it possible for us to get more convexity and not have that much duration? So unfortunately, they come from the same place, which is, if you remember your MACD, that your MACD is the part where your price risk is then not dominating anymore and your reinvestment risk starts dominating, right? And that only happens, and the sooner the MACD would happen if you had like a lot of nice coupons coming early in the life, because well, then if you had large coupons coming in, then higher interest rates would actually increase your reinvestment income. But the less coupons that you have and the more your money is stuck up for the long run, the more price risk you have. So lower coupon rate means higher price risk, which means higher duration. It means higher duration, which also means higher convexity, right? Again, lower interest rate environments means you're not really having higher reinvestment income on the coupons. So again, reinvestment income is low and greater convexity and higher duration as well. And the longer your money is stuck for, the longer the maturity, the greater the duration and greater the convexity. So they go hand in hand, right? Duration and convexity goes hand in hand. And the more the duration of a bond, the more the convexity. So that means it's not like you can get convexity and not get duration. So unfortunately, it doesn't really help us knowing that convexity is a good thing. However, if you have a very good view into interest rate expectations and you feel interest rate is going to go down, well, if you get a bond which is highly convex and also very high duration, and if the interest rate goes down, well, that bond is going to jump in price. So you can very well position yourself if you have that view into interest rates. And if it's going to go down, unfortunately, it will fall in price. So you can make a lot of money by buying bonds with high duration and high convexity if you know that the interest rates are expected to go down. Anyways, that is a practical discussion, and for the time being, let's prepare for your CFA Level 1 exam. And in order to do that, what we will be doing in the next video is applying the formulas for convexity, well, both duration and convexity, and calculating a bond's price change, right? We'll be looking at percentage change in the price and we'll be looking at actual changes. So in the next video, we're going to get into these calculations. So just take a break and then come back and let's get into the calculations.